Hello and welcome to the second video about measures in distributions. Last time we focused on the center, and today we will talk about the spread. In the future, I will make a video about measuring the position of distribution as well, so stay tuned. In this video, we will learn about the four primary ways of measuring the spread: the range, the interquartile range, the variance, and the standard deviation. But first, why is it useful for us to measure spread? Often when we describe a distribution, only designating an average value we talked about last time is not sufficient. For example, two communities may have the same average salary, even though one of them is made up of some very rich people and some low-income households, while the other only contains middle-class families. Therefore, it's very useful to indicate the variability or the dispersion of measurements, and that's exactly what spread tells us. The range of distribution is the most simplest, most easily calculated measure of spread. It is the difference between the largest and the smallest value. In this example, we quickly notice that the smallest value is 0, and the largest number is 4. So the range is 4 minus 0 equals 4. However, the range is entirely dependent on the two extreme values and is insensitive to the data in the middle. So we usually only use it to evaluate samples with very few items. Now, the interquartile range is one method of removing the influence of extreme values on the range. It is similar to the median and the range that we discussed before, so I strongly recommend you to review the videos on measuring the center of distributions and interpreting graphs before moving into interquartile range. Okay, the interquartile range is the difference between the largest and smallest values after removing the lower and upper quarters. That is, the 75th percentile minus the 25th percentile, which gives us the range of the middle 50% of values. What I prefer to do, though, is to split the numerically arranged data into two halves. Then find the median of each half, and the interquartile range is just the difference of the larger median minus the smaller one. Let's see another example. We first arrange the data from smallest to biggest. Then we split them into two halves. Find the medians. Then subtract. And we get the interquartile range is 3 as well. The interquartile range is also responsible for designating outliers numerically. We introduced outliers before in the video about interpreting graphs, so make sure to review that if needed. We define that a value is an outlier if it is more than 1.5 times the interquartile range below the first quartile or above the third quartile. We take the same two sets of data to illustrate this idea. We've already found the quartiles and the interquartile range, so we multiply 3 by 1.5 to get 4.5. 4 minus 4.5 equals negative 0.5. And 7 plus 4.5 is 11.5. Now, do we observe an outlier? Well, 17 is larger than 11.5, so it's an outlier. In the case down here, we repeat the same steps. Multiply the interquartile range by 1.5. 4.5 below the first quartile is 2, and 4.5 above the third quartile is 14. There's no value larger than 14, but 1 is smaller than 2, so it is an outlier. Variance is a tool to measure dispersions from the mean due to a multitude of chance effects. It is the average of the squared deviations from the mean. For example, to determine the variance here, we need to first find the mean. Next, we square the difference between each and every single element and the mean and divide it by the number of elements. The reason we add up the squares instead of just using the differences is that the positive and negative differences may cancel out. But since squares are always non-negative, the sum of all deviations from the mean will always increase. Just like how we have the mean of a whole population and the mean of a sample, we have a variance of the whole population and variance of a sample. While the former is denoted by the lowercase Greek letter sigma squared, the latter is represented by s squared. However, since the sample variance uses the sample mean, that may include some inaccuracy, we make the formula a bit different to minimize the errors. Standard deviation. While this name may sound scary, don't freak out. It's actually a simple idea now that we have introduced the variance. Standard deviation is just the square root of the variance. For example, here we know the variance is 40/9, so the standard deviation is just the square root of it, which is 2/3 of square root of 10. Corresponding to the variance of a whole population, the lowercase Greek letter sigma represents the standard deviation of a whole population. Similarly, s is the standard deviation of a sample. Here, the deviation x minus x bar are called residuals. Finally, recapping. Today we talked about measuring the spread in distributions. We introduced the range, the interquartile range, the variance, and the standard deviation, as well as how to calculate them. And that's all for today's video. See you soon!